Hello, welcome again. We are covering the topic Centrifugal Compressor for Civil Services Mains, IFS and Gate Aerospace exam. And in this, we are covering the subtopic Compressor Characteristics. And we have drawn a compressor characteristics for constant speed between pressure ratio and non-dimensional mass flow rate. And this was the curve we obtained A, B, C. So if we consider region between A and B, then this region is your unstable region. That is due to surging. Why? This can be explained by this figure. So this is your compressor. One represents outlet of compressor. Two represent downstream of compressor, and both are connected by a wire. Okay. So now suppose our operating point is your D point. Okay, D point. If at point D we reduce mass flow rate, then the pressure ratio will decrease. So it means the pressure at 1 will decrease at the outlet of compressor decrease because compressor is up to that. And here the decrease in pressure will be sensed quickly as compared to this downstream. So as there will be less pressure at point 1 and high pressure at point 2, so reversal of flow can occur. So reversal of flow can occur. So if reversal of flow is occurring, then this can lead to point A or shutdown of the compressor. A point means reversal of flow means mass flow is in reverse direction or there will be no mass flow after some time. So this can lead to point A. So there can be shutdown of compressor. Okay. So this is due to high pressure here and low pressure here. Okay. But after some time the low pressure is felt at downstream. Okay. And then the flow will start taking place in this direction. Okay. So there and it will be at high frequency. So as it is in high frequency, first the flow is taking place in this direction, then the flow is taking place in this direction. So then and this is occurring at high frequency. So this may lead to vibration in the compressor. This phenomenon is called surging. Okay. So now I will read out surging. In actual practice, though point A could be attained if desired, most of the curve between A and B could not be obtained owing to the phenomena of surging as explained below. So here these points cannot be obtained because of surging. Let us consider the compressor with impeller and diffuser with delivery valve at operational point on the curve is D. Suppose we have this operational point D and this is your compressor with 1 as outlet and 2 as downstream. It can be seen that a decrease in mass flow will be accompanied by a fall in pressure ratio. If we decrease some mass flow, then it will lead to decrease in pressure ratio. That is, the pressure decreases at point 1 because this is delivery point at point 1, but the pressure at 2 here, that is at downstream, does not fall quickly. Here the pressure will not fall as quickly as it falls here. The air will tend to reverse, so as there is high pressure and here there is low pressure, so it will tend to reverse its direction and flow back in the direction of resulting pressure gradient. When this occurs, the pressure ratio drops rapidly as the air is going in this direction, so mass flow is further decreasing, so pressure ratio will drop rapidly, and even point A or shutting the valve or no flow condition can occur. Okay. So this is your high pressure, this is your low pressure, and reversal of flow will take place. Meanwhile, the pressure downstream of the compressor has fallen also. After some time, here the pressure will also fall. Initially, there will be high pressure here, low pressure here, and after some time, uh, here the pressure will also fall. So that the compressor will now be able to pick up again. Now again the compressor will uh, start delivering high pressure, and it will move, and mass flow will move in this way. To repeat the cycle again, which occurs at high frequency, which causes vibration due to intermittent flow and hence unstable. So again here the mass flow will increase, so pressure, here will be high pressure, here will be low pressure, and after some time as we further decrease mass flow, so this will go on and it will cause vibration and it will become unstable. Okay, so now this there is less chance of surging when we operate the compressor between D and D, because because at this point, uh, the downstream pressure can fall at a greater rate as compared to this outlet pressure. But if we decrease the mass flow rate so much, then again this phenomena will start occurring. Okay. So this surging of air may not happen immediately. The operating point moves to left of B in figure, because the pressure downstream of compressor may first of all fall at a greater rate than the delivery pressure. Sooner or later, as the mass flow is reduced, the reverse will apply. The conditions are inherently unstable. But if we decrease the mass flow rate so much that the point D is also reached, uh, then this phenomenon, then this region will become unstable. Okay, so now if we operate the compressor here, here a decrease in mass flow will lead to pressurize. Okay. So as long as the operating point is on the part of characteristics having negative slope, however, decrease in mass flow is accompanied by a rise in delivery pressure, and stability of operation is ensured. Hence, there is less chance of surging beyond point D or between D and C. So, between D and C, there is less chance of surging. Okay. However, there is some negative slope, positive slope here also, but this is not so high. Okay. So, there is less chance of surging when we operate between D and C. When the curves are different, drawn for different speeds, and joining point D constitute the surge line. So if we draw, this is your single curve for a single speed, that is n by root t 01. So if we draw the curve for different speeds, and then this is your this line is corresponding to point D. So this is for different speed, this is for different speed, this is for different, and this is point B, and this is your locus of points of maximum chance. Okay. So this is about surging. Next we will talk about stalling and